Hello dear, how are you all? Today we learn how integration is reverse process of differentiation. This is my second video about integration and we will continue this sequence of integration until you understand the whole concept of integration. Today we learn how integration is reverse process of differentiation. Suppose we have some curve, for example, y is equal to x square. In first case, y is equal to x cube plus 3x. In second case, and y is equal to x to the power 4 plus 5 in third case. We know find their gradient function. How can we find their gradient function? We just differentiate one by one. To differentiate, we apply here power rule. You know power rule? Power rule is that when we have to differentiate a function, for example, we have a function f of x is equal to x to the power 4. How can we apply power rule to differentiate? We just multiply the function with power of function and then reduce power 1. For example, if f of x is a function, its derivative will be f prime x is equal to 4, which is the power of function, multiplied function by reducing power 1. Its derivative is equal to 4x cube. We just multiply the function with the power of function and then reduce power 1 when we apply power rule. It is a simple way to differentiate the curve or to find the gradient function of any curve. The gradient function of this one will be dy by dx is equal to 2x, and in this case dy by dx will be 3x square plus 3, because derivative of x, which is variable, derivative of any variable with respect to itself always 1, and in third case derivative of x raised power 4, 4x cube. For a moment, we suppose we are only given these gradient function. I mean to say, we suppose for a moment we are all only given these gradient function and it is asked to find actual function whose gradient functions are given. It is asked to find the actual function whose gradient functions are given. We have to find these functions from these gradient functions. Suppose we don't any idea, we don't know anything about these original functions, and we have to find these gradient function. Suppose we have no idea about the original functions whose gradient functions are not given. We are given only these gradient functions and we have to find the actual function whose gradient functions are given. For a little bit of time, you will be surprised, you will think, how did we find these gradient function? Obviously, by differentiating, we did find these gradient function. You know, differentiation is a process by which we find gradient function of any function. Now in order to find the actual function, we have to search such operation that will be the reverse process of differentiation. This reverse process of differentiation is called integration. In integration problem, we have to check whose differential or derivative is given. For example, there is a gradient function dy by dx is equal to 3x square plus 3. We have to find out the actual function whose gradient function is this. We have to apply here the process which will be the opposite to the differentiation. You imagine which is the function when we differentiate and we get 3x square. Obviously, when we differentiate the function f of x is equal to x cube, we will get its derivative, which is 3x square. Which means when we integrate this, we will get x cube. And when we differentiate x cube, we will get 3x square. And when we integrate 3x square, we will get x cube. That is why derivative and integration is reverse process of each other. We know integrate this. How can we integrate? We just first separate the variable. Dy is equal to 3x square plus 3 multiplied dx. This process is known as separating the variable. After this, we have to integrating on both sides involving the variable. We integrate this side with respect to y. Integral of dy is equal to integral of 3 x square plus 3 x. This sign is used for integral or integration. We take 3 as a constant. Now, how can we integrate this x square? Look at this example. When we differentiate x raised to power 4, we apply power rule. In power rule, we just multiply the function with power. We multiply the function with power, but in integration, we divide the function by power. How? In differentiation, we have to multiply the function with power of function, but in integration, we have to divide the function with power. When we multiply the function with power of function, which is 4, we multiply the function before decreasing 1, but in integration, we divide the function by power after increasing 1. Which is a theme of real theme of integration. In differentiation problem, when we multiply the power with function of power, when we apply the function with power of function before decreasing 1. Before decreasing 1, this is 4 and this is 3. Before decreasing 1, we multiply the function with power. But in integration, we divide the function after increasing 1. Is it clear? After increasing 1 means we have to divide this function by power after increasing 1. We have a power 2. After increasing 1, we have a power 3. We divide this function by 3. For example, in simple case, if x raised power n, we have to integrate this. We just divide the function with power after increasing 1. Here power of function which is n, we divide the function with power n plus 1 because we have to increase 1 in this power and then divide the function. And x raised power n, its integral x raised power n plus 1 divided by n plus 1. In differentiation we decrease power, but in integration we increase power 1. According to this formula or technique, here we write integral of x square which is equal to integral of x raised power 2 plus 1 divided by 2 plus 1 plus 3. Here is 1, and each process of integration is inverse process of differentiation. Each process of differentiation is inverse process of integration. 1. In integration problem we have to check whose differential is given. 1. When we differentiate x, its derivative 1, so its integral 1 which will be x. Derivative of x which will be 1, but integral of x 1 inverse order which is x. So integral of dx which is x plus c, we get 3x cubed by 3 plus 3x plus c. After cancellation we get x cubed plus 3x plus c. Will come from this c. C is a constant, we have to add this constant in integration problem from our side. To understand this, look at this. If we have a y-equal function x cubed plus 4x square plus 5, its derivative is plus 0. Derivative of any constant is 0. I mean to say, in differentiation we have to eliminate this constant, or we have to remove this constant, we have to finish this constant, but in integration we have to add a constant from our side. In each problem from our side we add any constant. For example, any arbitrary constant, small a, small b, we use. Let's take one more example to understand this. Suppose we have to integrate this function. First of all, we have to reduce its strength. For example, we integrate each portion separately. We apply a technique when function has power n, we increase power 1 and then divide the function with same power. I mean to say its integral x raised power 3 plus 1 over 3 plus 1 plus 3 as a constant, x raised power 2 plus 1 divided by 2 plus 1, 9, x raised power 1 plus 1. The last, integral of dx, we have to check. This is 1. Whose differential is 1? 1 is the differential of x. When we differentiate x, its derivative is 1, and when we take integral of 1, which is x, we write 2x plus c. After simplification we get 1 by 4, x raised power 4 3 by 3 x raised power 3 plus 9 by 2 x raised power 2 plus 2x plus c. We again write 1 by 4 x raised power 4 plus x cube plus 9 by 2 x square plus 2x. This is the actual function. When we differentiate this function, its gradient function will be this. In this way, we can say that integration and differentiation are reverse process to each other. Thank you.